All right, folks, this is the last way we are learning in this chapter how to calculate the delta H of a reaction. This last way is we're going to use the enthalpies of formation that are listed in the back of your textbook. So an enthalpy of formation has a symbol looks like this. And we'll talk about where these numbers come from. So this compound, so here's the important thing. Compounds predictably release the same amount of energy when they are formed under the same conditions. Okay, so what scientists have done is they've measured how much energy is released when compounds are formed at 1 atmosphere and 25 degrees Celsius to keep the conditions consistent. And when those are formed and they measure the energy, that's your delta H of formation. Okay, again, it's the change in enthalpy, which again is our heat change with the formation of 1 mole of a compound from its elements, keyword from its elements, in standard states. Okay, when I say standard states, I'm talking about 1 atmosphere and then 25 degrees Celsius, and then whatever phase the compound is at room temperature or at 25 degrees Celsius. And then if you're looking at an aqueous solution, it's going to be a 1 molar solution. Okay, here's the important part. We're looking at forming compounds from their elements. So for example, if I wanted to make CO2, I would have the element carbon combined with an O2, and that would make 1 mole of CO2. Okay, so that's what it means from their elements. Okay, so when CO2 is formed from the elements carbon and carbon and oxygen, we can measure the amount of energy released when carbon dioxide is formed, and that will be its delta H of formation value. Okay, noticeably, pure carbon and pure oxygen have delta H of formation values of 0 because they're like the ingredients, they're not compounds, and so ingredients are always going to be a delta H of formation of 0. Okay, there is a big file of these values in the appendix of your textbook. It's page 100. I'm sorry, 1100 in your textbook. Okay, so if you flip there, you'll see a ton of these just listed in tables for all the different compounds that exist. Okay, so we use the delta H of formations to calculate delta H of reactions using this formula. Okay, so there you go. Oh, did I forget something? Oh gosh, I forgot something, guys. There should be an N right here. Okay, so when you do this equation, this is what this means. So the brackets just are mathematical. They isolate this part of the reaction. So what you're doing is the sum of, if you guys ever see that Greek letter sigma, that's what this is. This is a capital sigma. If you ever see that in science, it means the sum of, okay? So it's the sum of the number of moles of the delta H of formation of the products minus the sum of the number of moles of the delta H of formation of the reactants, okay? So we'll walk through an example of what this looks like. So calculate the delta H of reaction for the following reaction using the standard enthalpies of formation. That's your delta H of formation for each compound listed here. So guys, keep in mind, these are the reactants, these are the products. Take a look at the order it comes in. So we're going to do the products minus the reactants here. So please keep note of that order. So the first thing we're going to do is look in the back of the book and look up what the delta H of formation values are for all 4 of these compounds. So let's do that really quick. I'm going to do that for you guys. So our delta H of formation values for, let's see, we're going to have to look up CH4. We're going to have to look up O2. CO2 and H2O. So when you go to the back of the book and you look up these values, we're going to get negative 75 kilojoules per mole here. Oxygen is elemental. It's a pure element, so that's going to be 0. Everything that's like elemental form is going to be 0. So if it's not a compound, it is 0. Whoop. That's a 3. And H2O. All right. Now that we have these looked up, we can plug them into the formula. So the delta H of this overall reaction. So let's do products first. We have 1 CO2, so that's going to be and the other product is our H2O. Notice, guys, we have 2 H2Os. So what we're going to do is we're going to take the value of the H2O and make sure we multiply it by 2. Okay, so here's the values for our products, and we're going to subtract the values for the reactants. On the reactant side, we had 1 CH4. And then we had 2 O2s, which is 2 times 0, technically. Okay, so there you go. So in your calculator, you're going to crunch out what this number is. Okay, so this number plus 2 of those, and it's going to subtract whatever this number is. Okay, so the delta H of formation is negative 891 kilojoules per mole reaction. All right, there we have it. Okay, oh, my little brother left this as a surprise for me. He borrowed my iPad. Funny. You would think he's a little kid. He is 34. Oh my gosh. Okay, so let's look at this next example. Let's see. Okay, so again, we're going to do the same thing. We're going to look up our delta H of reaction, or I'm sorry, formation for each of these compounds. So let's see. All right, we've got to have NH3. We're going to have O2, NO2, and H2O. NH3 is negative 46. O2 is 0. NO. And H2O. All right, let's do it. So delta H of reaction. Again, the products come first. Products come first. So we're going to do the 4NO2 and then the 6H2O. Followed by the reactants. We had 4 NH3s. And then technically 7 H2O, but it's 7 times 0. Okay, so in your calculator, you're going to crunch out what this number is and what this number is, and then subtract them. And you'll get, let's see, the delta H of reaction for this overall reaction is negative 1396 kilojoules, which I feel like I can only have 2 sig figs, so this is going to be negative 1400 overall. Okay, so there you have it. That's how you do it. And I realized I just labeled this wrong. This guy should be delta H of reaction, not formation. Okay, looking good. So there you guys have it. Did I get the sig figs wrong on this one? Of course I did. This should be negative 890 kilojoules. There we go. Okay, so if you guys need anything, let me know. Feel free to reach out and go ahead and tackle your homework.